Here we are in section 5-5, exercises 1 through 12. It says to solve by factoring. Now remember, when we have an x-coordinate equation and x's, we can't combine like terms. So everything we learned about how to solve equations back in chapter 2 that we used in 3 and 4 was useless. So we had to come up with a new way. And this way was that if we get it equal to 0 and factor it, that we then have things timesing. That's what factoring is things that multiply to equal 0. And we know all the 0 times tables. 0 times anything is 0. So this is like the best number to multiply to. We factor it in one of our 5 different methods. Could be greatest common factor, grouping, trinomial with leading coefficient 1, trinomial with leading coefficient not equal to 1, or a special case, either a binomial or perfect squares, perfect cubes, stuff like that. So that's a reminder of all the different methods we'll have. Well, once we have it multiplied to equal 0, then if we just let each little piece equal 0, it will give us an answer because we're multiplying. If the first piece equals 0 and it times something else, it still equals 0 and we have an answer. So that is our pattern there. So let's do it. Number 1. Get equal to 0. Notice that all of these are already equal to 0, except for that one right there. We'll have to work on him, but all of these are equal to 0. We're at equal to 0 now, so now we factor. So we consider, do we have a greatest common factor? No. How many terms? 1, 2, 3. 3 terms. Leading coefficient 1, that means this is going to be a fast one. And we take the number 12. That's a 1 and a 12, a 2 and a 6, or a 3 and a 4. And that means x plus 3, x plus 4 equals 0. So now we factored it, and that's usually the hardest part. Now we just take each factor and set it equal to 0. So if x plus 3 equals 0, then x equals a negative 3. If x plus 4 equals 0, then x equals a negative 4. Oh, I like how that works. All right, let's try number 2. Get it equal to 0. Check. Factor. Leading coefficient is 1. We have 3 terms and we don't have a greatest common factor, so this is going to be a nice easy one. There's a negative 12 out there. A 1 and a 12, a 2 and a 6, or a 3 and a 4. And if we look at this, this is m. Let me see. It's a negative 12. We've got to add to a negative 4, so a plus 2 and a minus 6. And then set each piece equal to 0. M plus 2 equals 0 gives us m equals a negative 2. M minus 6 equals 0 gives us m equals 6. And you can actually take those back and try them out, and they actually work. It's pretty cool. Number 3, get it equal to 0. Check. Factor. Do we have a greatest common factor? No. 3 terms, leading coefficient 1. That means it's going to be a fast one again. That's nice. They gave us a few easy ones to begin with. X and an X. Negative 40. What times is to negative 40? That's a 1 and a 40. That's a 2 and a 23. Nope. 4 and a 10 and a 5 and an 8. And it's negative. So one of these guys, one side has to be negative. And what adds to a positive 3? Those guys right there. So it's x minus 5, x plus 8 equals 0. Now that it's factored, these two things are multiplying to 0. We get an answer if just this guy's 0, or in other words, if x equals a 5. And we also get an answer if this is a 0, which means x equals a negative 8. Yes, indeed. Right there. Good. So notice this number right up here, the 2, will tell us how many answers we have. Every time it's a squared, we'll have 2 answers. When we get like a cube down here, we're going to have 3 answers. All right, number 4. Get it equal to 0. Check. Factor, greatest common factor, no. 3 terms, leading coefficient 1, so it's going to be a nice easy one again. What multiplies to a positive 18 and adds to a negative 9? 1 and 18. 2 and 9. Oh, no, we're trying to add to 9. There's a 9. 3 and 6. Those add to 9, but it's negative, so it would have to be a negative 3 and a negative 6. Do those add times to a positive 18 add to negative 9? Yes. So x minus 3, x minus 6, that equals 0. Now it's factored, so it's this blob times that blob. make this one x minus 3 equals 0, and we get x equals a 3. And you'll notice that's the pattern. This is the number we get is exactly opposite of that. Kind of nice. X minus 6 equals 0, and that gives us x equals 6. And we have two answers there. All right, number 5. Very similar type thing here. Get it equal to 0, check. Factor it. Is there a greatest common factor? No. Leading coefficient 1 on a 3-term polynomial, so this is going to be a nice one like this. Negative 24, so that's a 1 and a 24, 2 and a 12, 3 and an 8, 4 and a 6. And what adds to a negative 23? That'd be a negative 24 and a positive 1. Double check that. It times us to negative 24, adds to negative 23. So we get a plus 1 times a minus 24 equals 0. We've got it factored equal to 0. Take each piece, a plus 1 equals 0. That gives us a equals a negative 1. That will cause this one to go to 0, and a minus 24 equals 0. A equals 24. So that gives us those two answers on number 5. All right, with number 6. Get it equal to 0. Check. Factor it. Is there a greatest common factor? No. 3 terms, leading coefficient 1. So that means this is going to be a nice slick one again. Looks like we'll get leading coefficients not equal to 1 later on, but right now, these first 6, they were nice to us. So it's going to have an x and an x, and then we're trying to get to a negative 24, just like number 5. So we have a 1 and a 24, 2 and 12, 3 and 8, 4 and 6, and, negative 4 and negative 6? No, we're trying to get to a negative 24, so only one of them can be negative. Negative 2 and positive 12. Negative 12 and positive 2. Let's double check that that's right. Negative 12 times 2 is negative 24, and they add it. Yes, it's got to be a negative on the 12. When that's equal to 0, set this one factor each equal to 0, and we get x minus 12 equals 0. We get x equals a positive 12. And then the other one, x plus 2 equals 0. We get x equals a negative 2. And ta-da, we got it. All right, number 7. Get it equal to 0. Check. Factor it. Okay, greatest common factor looks like 2 and a y. And we're left with 6y squared minus 11y minus 7 equals 0. This piece is still a trinomial with leading coefficient not 1. So we have to take 6 times negative 7, AC method. 6 times negative 7 is a negative 42. Could be a 1 and a 42, a 2 and a 21, a 3 and a 14, or a 6 and a 7. Let me see. Looks like a 3 and a minus 14. Now remember, this is the AC method, so it goes a little bit slower. We break this up into its plus 3y minus 14y. Oh yeah, this is going to take a little while longer. Okay, so now we have 1, 2, 3, 4 terms here. Cut this guy in half, pull out the 3y. We're left with 2y plus 1. Oh, let's use that different color since we're doing grouping right now. Let's put this different color in here. We get 2y plus 1. Don't forget we have the 2y way up yonder. We'll come back and use him in just a minute. Minus 7. And we pull out, and that'll leave us with a 2y there and a plus 1, which means we pull out the 2y plus 1 now. We get 2y plus 1. And then 3y minus 7, and then this 2y is way out in front. Okay, so that was the factoring, and sometimes that does take a little while. That is all equal to 0. Okay, so now what? Well, it says, okay, we got factoring done, so now step 3, each piece equals 0. So we set this equal to 0, so we get 2y equals 0, and that will give us one of the answers. I'm going to write them over here, y equals 0. Good deal. I'm going to use this color to separate it. If I write down 2y plus 1 equals 0, now if you solve this little itty bitty equation right here, you would subtract 1 and then divide by 2. So you'll get y equals a negative 1/2. That's an answer as well. And I'll write this down even in a different color, even though it's blue here. We're going to write down 3y minus 7 equals 0. You would add 7 and then divide by 3. So you would have y equals 7 divided by 3. These are your 3 answers. And notice what we have right up here. It is a cubic equation, a third-degree polynomial, and there are 3 answers to it. Yeah, that's exactly right. Whew. That was a long one, but that's exactly it. You factor it, and you have to use all the rules of factoring to get it down here. But once it's here, you have something times something times something equals 0. So if you make the first thing equal 0, you get an answer. Make the second thing equal 0, you get an answer, and make the third factor 0, and you get an answer. And so 0, negative 1/2, and 7/3. All right, let's try number 8. Get it equal to 0. Check. Okay, got that. Now factor. This is any greatest common factor? No. 2 terms, and there's a subtract sign, so this will be a difference of squares or difference of cubes. 25 and 9, they're both perfect squares. So this is 3x plus 5 and 3x minus 5 equals 0. So now let's set each piece equal to 0. And this one we'll be able to do a little slower motion than we did down there because we've got some room. 3x plus 5 equals 0. Subtract 5. 3x equals a negative 5, and divide by 3, x equals a negative 5/3. That's one of the answers. Now when we do it over here, 3x minus 5 equals 0. Add 5 and you get 3x equals 5. Divide by 3 and you get x equals a 5/3. Shazam! Right there. All right, number 9. Let's go with, okay, we've got equal to 0, check. Factor. Is there a greatest common factor? No. It's a trinomial, 3 terms, leading coefficient is 3. So we're going to have to use the AC method. So 3 times 7 is a positive 21. That's a 1 and 21. 3 and 7. All right, so we got to add to a negative 22. So those guys have to be negative. And then it breaks up. 3x squared minus x minus 21x plus 7. All right. Looks like grouping now, because that's what AC method does. You break up that guy, you have 4 terms, grouping, chop it in half. And we now have x. Let's use a different color right now. 3x minus 1. And then minus, what can come out here? A 7? Yeah, indeed. And it's now a 3x minus 1. Excellent. So that is, pull the 3x minus 1 out, and we're left with the x minus 7. And now don't forget, all that equals 0. So now that we factored it, we have 2 things timesing together equals 0. Each piece equals 0 will give us an answer. So here we take 3x minus 1 equals 0, add 1, divide by 3, and we get x equals 1/3. And here, x minus 7 equals 0, add 7, and we get x equals 7. So here are the answers for those guys. And you guys can pretty much get that shortcut. You're like, wait a second. Opposite of this, positive 1 over 3. Yeah, because you have to solve it. Positive 7 over 1, and it works. Good. Let's look at number 10. 8w squared minus 10w minus 3 equals 0. Get it equal to 0. Check. Factor it. Is there a greatest common factor? There is not. 8 times negative 3. Oh, trinomial, leading coefficient not equal to 1. It's not a perfect square. And so 8 times negative 3 is a negative 24. We've got to use the AC method. So negative 24 could be a 1 and a 24, 2 and a 12, 3 and an 8, 4 and a 6. Right. I think we've done a couple of negative 24s up here. They've all been different each time. On this one, it's a negative 24. It's got to be a negative 12 and a positive 2. Oh, similar to what it was up here, but this one is to split the middle term. The AC method, you split this, so you have 8w squared plus 2w minus 12w minus 3. That's equal to 0. We now have 1, 2, 3, 4 terms. Chainsaw. We now have a binomial here. What can we take out of it? 2w, and it's left with 4w plus 1. All right. And this one, take out a minus 3, and we're left with 4w plus 1. So we now have 4w plus 1, and the other guy is 2w minus 3. And remember that all of this equals 0. Let's not forget that. The factoring, that was last section, and we mastered that. So now we have this times this equals 0. So we got it equal to 0, check. We factored it. Now each piece has to equal 0. So this one, 4w plus 1 equals 0. Subtract 1 and divide by 4, and you get w by itself. On this one, 2w minus 3 equals 0. Add 3 and divide by 2. And there we have it. W equals a negative 1/4 or a 3/2. Perfecto. Let's keep moving. Number 11. If we have x squared minus 9, oh, we're not equal to 0. Step number 1, get it equal to 0. So subtract 9, subtract 9. X squared minus 9 equals 0. Now we factor. Is there a greatest common factor? Nope. How many terms? 2 terms. We're looking for a special case where it is a difference of something. Difference is subtraction of 9 is a perfect square, x squared is a perfect square. So we actually get x plus 3, x minus 3. That equals 0. So now let each one of these equal 0. X plus 3 equals 0, and that gives us x equals a negative 3. X minus 3 equals 0. X equals a positive 3. And notice that we actually found both answers. Some people might look at the original equation, x squared equals 9, and be like, oh yeah, I solved it. The answer's 3. But there are 2 answers. We see that 3 squared is 9, but negative 3 squared is also 9. Excellent. All right, number 12. Ooh, look at this one. Oh boy. This looks huge. Get equal to 0, check. Factor. Is there a greatest common factor? Oh, good. There is a greatest common factor here. Does 16 go into everything? No. I think 4 is as big as we got. 4, we get 25x squared plus 20x plus 4. And that's going to equal 0. Now what's left is a trinomial, leading coefficient not 1, 25x squared. Ooh, is this a perfect square? We don't even have to do the AC method if it works. 5x plus 2 squared. Let's see if it double checks out with the pattern. 5 times 2 is 10. Doubled is 20. Yep, indeed. Here's our... We factored it. Yay. We may need to write it so you can see what's going on. This is a 5x plus 2 times a 5x plus 2. That may be helpful to see that. Now, each piece equals 0. Well, here's a piece. 4 equals 0. That doesn't give us an answer. That doesn't even make any sense. So now we do 5x plus 2 equals 0. And that gives us subtract 2. And then divide by 5. And we get x equals a negative 2/5. And this one will just give us the same thing. So this guy happens, but he happens twice. So we still actually have 2 answers. They just happen to be the same number. Negative 2/5. Excellent.